All right, so here is Unit 1.1. First section within this is just going to be combining like terms. So when we're combining like terms, we're going to be looking for things that are going to have similar properties like letters, exponents, not necessarily the number in front, because addition, subtraction, multiplication, and division all can happen within these. So let's get into some of the examples. So first thing that I want to just highlight here, okay, is the definition. So an algebraic expression, like terms are the terms that have the same variables raised to the same exponents. Constant terms are also like terms, and to identify like terms and like terms in an expression, first write the expression as a sum of its terms. So what that's telling us is basically we need to have like two things that have the same letter, same exponent in order to be able to add them. The number in front doesn't necessarily matter to us because we're going to be writing that first, or the coefficients, those numbers out in front, as a sum of its terms. So we can write them like this, which then tells us that we would have 7x squared. So just some more examples to get into down here. Something that I think is really good for organization is color coding, changing what kind of tool you're using to help you kind of identify. Now, you can box, underline, highlight, circle, whatever you are feeling, but whatever you are doing, I would make sure that you are always including the number or the thing that comes in front of your letter. Like this guy doesn't have anything because that's our first term, but that X has a negative. Now, when it's just negative right there, that means that there is a 1 hiding. So when I'm combining those, I'm reading it as 9x minus 1x because I'm taking that sign that came from the 1x with me, which then tells me I have 8x. Then I'm going to look at my next two pairings and say, okay, well, if I have a negative 2 plus this 7 here, well, negative 2 plus 7 is a positive 5. Then, kind of final step here, and again, this is kind of taking the long way, writing out each piece, but if this is helpful for you, do it this way because there's no wrong way to do it. It is just a little bit more work. But because that 5 is positive, it's a plus. Because that 8x is positive, there's nothing in the front, and there are like terms. Simplified. Okay, now same thing happens over here. We're going to do the exact same steps. Underline, highlight, box, again, the things that have the same letters and exponents with them, and then we can rewrite them. Again, when it's just the letter and there you don't see anything in front, it's not a 0 because a 0 would imply that it's gone, but there's going to be a 1 there. So I'll have 1z squared minus 3z squared, and we have to go in the order that it is given, left to right, just like a book. So I can't flop them just because I don't want to deal with a negative. I have to keep them like this. So 1 minus 3 gives me a negative 2z squared. Okay, then my next couple terms that are together, a positive 5z and a positive 1z. So I'll have 5z plus 1z, which gives me 6z. Now again, 6z is positive, so when I go to write these, I know I have a negative 2z squared plus a 6z. Okay. All right, so there are our first two examples. Let's try a couple more, and then I'm going to have you try a few on your own. All right, so taking a peek at the first one here, it's already going to be intimidating because we have a fraction in front of that third term there. Don't let that be the thing that trips you up here. We know how to handle fractions, and this fraction is actually a really nice one. So if you're ever unsure, what you can do is take this number, and we can plug it into our calculator and say, okay, well, 3 divided by 2, that gives me 1.5. If you would rather see a decimal out in front, check to see if it's a nice decimal, like that conversion from fraction to decimal. There's a button on your calculator that does it. If you ever want to see that, feel free to bring it over to me, and I would love to show you. So 3 halves or negative 1.5, because again, that negative in front matters to us here. I have a 1 in front of that y. So really what this is telling me is 1y minus 1.5y, or again, you could say 3 halves, but that is going to give me a negative 0.5y, okay, or negative 1 over 2. Again, fractions and decimals, and you're going to learn in this class, I don't care which ones you use. Sometimes there are better options, like if I have a repeating decimal, like 0.3 repeating, which is 1/3, I would prefer you use the fraction, but with something like this, where it's half and it's a really nice decimal, I'm not picky, okay? Then, the only other thing we have here is 10. Well, 10 equals 10. So then I can take my terms, and I have a negative 0.5y plus 10. All right, checking out the next one here. Number 2, go ahead, start underlining things that are the same. Again, anytime it's just that letter, I always throw that 1 there just in case, because I want to make sure that I don't forget it when I'm going through and doing these. So I'll have a 2r squared minus a 1r squared to give me a 1r squared. Now, I can also kind of use that same thing and now just say, well, it's r squared. Because that 1 out in front, I don't have to have it. Because 1 times anything is just itself. Okay, so you could use either version. I'm okay with it. Then we're going to look at our next one. Well, I have a 7r. Nothing is paired with that. So 7r doesn't change. And then I'm going to look. Let me change my color one more time. I've got a negative 9 too. And that doesn't change anything either. So when I go through and I write this now, I'm actually going to have 3 pieces left, which is okay. So I have a positive 7r, or a positive r squared, a positive 7r, and then a negative 9. Okay, now again, going through all these steps I'm taking with the different colors, you don't have to do that if you are feeling really good with this, right? If you know the 2r squared minus 1r squared is just 1r squared, or it's r squared, you don't have to write that step. But if you're getting a little bit unorganized with your thoughts, this is a great way to reorganize them. All right, here is another one. Go ahead, start underlining things. So I've got a 4p and a positive p. So 4p plus a 1p is going to give me 5p. Okay, then I'm going to look at my next grouping. Well, I've got a 7 and a negative 5. So 7 minus 5 gives me 2. And then my third and final term here is just a 2q that doesn't have anything else that partners with it. So it just stays as is. Now that one was a little bit confusing because why would they use 2 letters that are very, very similar like that? But is what it is. Just make sure you know what you're working with. So positive 5p, a positive 2, and a positive 2q are going to give me those answers. All right, hopefully at this point you are feeling a little bit better about it. When we talk about these answers that we're getting to, the correct term for it is simplest form, so we're simplifying. So I would simplify. Okay, everything that we've had so far, when we simplify that final answer that I've written in black and circled, notice there has not been a single equal sign. Okay, the only equal signs that we're seeing are the ones that we are writing when we are separating our pieces that we have to combine together. So there's no equal signs. There's one of every letter exponent combination, meaning I don't see an x squared on the left and an x squared on the right still. They're combined down into one thing. So you could say one of each letter that should be a left. Okay, so there is one of each letter exponent combo left, and there's no limit on the number of terms that you have left. Like I could simplify it all the way down to 1 term if the conditions are right for it, or I might start with 5 terms and I can only simplify it down to 4. So there's no set number on how small you have to get it. Okay, so that's the difference. We're going to talk more about solving, and that's going to be where we have x equals blank. But we shouldn't be having any of that right now. Right now, you should still have numbers and letters attached together, all that good stuff. No equal sign, right? If you don't start with one, you shouldn't finish with one. All right, let's go through and do a couple of these. Hopefully we're feeling a little bit better on it now. Yeah, let's rapid fire through them. So 6n minus 10n, well, 6 minus 10 going left to right gives me a -4, and then that letter just gets combined together. Going to number 2, again, going left to right, I can't go 12 minus 4 because I want to. I have to go left to right. 4 minus 12 is -8. And then y is just my label. All right, go ahead and at this point pause this video here. I want you to try these 3 on your own. Give yourself some time. I'm just going to pause myself here for about 10 seconds. Then I'll go through what each of them should be. And then that is the end of this first lesson. All right, so just like the top, we have to go left to right. So -10 plus 15 is a +5, and y is my label. Looking at number 2, first thing I'm noticing is that they are fractions and that they don't have the same denominator. When you're adding and subtracting fractions, you have to have the same bottom part of that fraction. So because 4 and 8 are related, I can actually just multiply this second one by 2 to then get 3/8b minus a 6/8b. Because now they have that same denominator, I can actually do that math. When you're subtracting fractions, as long as the denominators are the same, we can just worry about the top. So really it's asking me 3 minus 6. Well, 3 minus 6 is -3. Bottom of my denominator does not change, and that label out in front does not change, or out on the back. Okay. All right, third and final one for lesson 1 of algebra. We've got 8s minus 11s plus 6s. Now, again, left to right. So when I'm going through these, I would probably simplify the first 2 first and then worry about this plus 6s secondary. So 8 minus 11 gives me -3s, which then -3s plus 6s gives me a +3s. All right, there is that first lesson.